Wanted to review some of the things we talked about in class this week for those folks who couldn't be there. First of all, this week should be mostly review, although I understand that some folks have never programmed in C without the plus plus, so they've always used C++. And there are a few little differences that we should bear in mind when we're in that situation. So let's start with a very simple program. It's all it does is declare some variables. It doesn't really do anything, but it does run the size of function many times to look at the size of things. And it also uses printf to print out the result of the size of function. So let's talk about that. First of all, in C++, do you guys use cin and cout to get text in and out of your programs? In C, there is no cin and cout, but there is printf and scanf and things like that. So printf is the easiest way to get output to the screen in a formatted way. And so we're going to be using that right away. It's defined in a header file called stdio.h, which is standard input and output. And I want to pound define a macro called n to be 10. And what that does is allows me to use that symbolic form in the program, and if I want to go back and change the size of arrays and things like that, I can do it. Okay, so what I want to do is take this simple program and let's copy it. And I'm simply going to pop over to my Cloud9, wherever that is. Maybe it's over here. Ah, there it is. And I'm going to, I've been fiddling here. Let me go ahead and paste that exact program in. And let's run it. So I just say run, and it goes. And you'll notice what it does is it defines these variables. Foo is a pointer to character. X is an array of n integers. Blah is an array of n characters. So when it says size of star x, remember an array name smells like a pointer. In other words, you can use it as if it were a pointer, and it's okay. Now, what you can't do is assign any pointer to it. So if you have a pointer variable, like a car star x, and it's not an array, then you can assign x to point to any integer you like. But when it's an array declared in this way, then you can't assign it to anything. It's fixed. But you can treat it. It behaves like a pointer in terms of how you access the memory associated with that array. So if I say, what is the size of star x, that's the size of the thing pointed to by x, that should be the size of an integer. So it comes out here, it's 4. So on this particular machine, with this particular operating system and compiler and so on, the size of an integer is 4 bytes. Star foo is foo is a pointer to character, so star foo should be a character, and that turns out to be 1 byte. Star blah is an array of character. So star blah is a character, because blah behaves like a pointer. So star blah is a character, so that's also 1 byte. Now what about the size of x? Well, x is declared as an n-element array of integer. And we already know that star x has a size of 4, so that means x must have a size of 40, because it's 10 integers. That makes sense. Size of foo, it says size of foo is 8. Well, foo, unlike star foo, foo is a pointer. So that what that means is on this system, a pointer requires 8 bytes. Whereas the thing it points to, star foo, only takes 1 byte. So it's 8 times the pointer is 8 times the size of the thing it points to, which seems a little inefficient, but well, pointer is a pointer. That's what it is. So size of blah. Blah is a array of characters, so it behaves like a pointer, so it's going to be the same thing. It's also, well, actually it says it's 10, so this particular, that's interesting. Oh, no, it's blah is not the, oh, okay. Blah is the array of character. Character each takes 1, and the size of the array is 10. Okay, so foo is definitely a pointer. Blah is an array of character, so instead of taking up 40 like x does, it takes up 10. Okay, Now that we've got that all straightened out, one thing I want to point out is that you can run these kinds of programs in a debugger. I can click over here to the left of the line number, and then if I turn on this green, so you'll see this little bug guy, if I turn that guy on and then hit run, instead of just running straight away, it actually runs in the debugger, which means I can step through the code. This little step over guy is what you'd use to step over function calls. This is what you'd use to step into function calls. This is what you'd use to clear all the breakpoints, and this means just go until you hit another breakpoint. So I'm going to use step over, and you can see here I've got the X array listed. It's just got random junk in it. But once I assign it to the empty array, it sets all the array elements to 0. And then I'll do the same thing with the blah array, and it sets all the elements of the character array blah to be the null character. Okay, that's the 0 character. And then of course I can see it's calling printf to print all these guys out. By the way, the format character I'm using in these printfs is %d, which means integer, and that's why I'm also casting the output of size of always to integer. So those the output of size of and the format specification match. Okay, so that's all there is to that. Oh, I just restarted the whole program. There we go. That runs the whole thing and it shuts down. Okay, so if you followed the other video, you should end up with the Project 1 folder on your Cloud9 instance. And in that folder, there's a folder called source, and in that source folder, there's a file called impl.c. This is where you're going to do all your work. There's a series of functions here that are described, and your job is to write the functions so that all the tests pass. Now, the first function, for example, is given an array of character pointers, which also is equivalent to a char star star. Count the number of consecutive non-null pointers. So you're going to go and write some kind of loop that goes through the array and counts the number of pointers in the array that aren't null. Once you hit the first null pointer, you're done. Then that's the end of the list, and you should return the count of non-null pointers. That would be the length of the array. So this guy's called array length. Then there's an array compare function that compares two arrays. There's an array copy that copies one array to another. Array element swap. This is a function that's actually described in the textbook, so you might want to read about that. And then there's a couple of, there's two sort functions. One that you're going to use the built-in library quicksort, and you'll pass it this function, which is a comparison function that compares two elements of an array of pointers. And then there's array bubble sort that you'll write on your own that does the whole thing using the bubble sort. So I'm sure you guys have seen bubble sort before. If not, then ask and I'll help remind you what that guy is. Okay, so that's the whole assignment 1. Now you need to be able to build assignment 1. So that's not too bad. You go to the window, create a new terminal. I'll just drag it down here so it's so I can look at the code at the same time. Now, in the workspace, if you do an ls, you'll see that project 1 is a subdirectory of that workspace. So I'm going to change to project 1. Now I'm in here, and notice there's a make file. So that means I can type make, and it says it's already up to date. I'm going to make clean, and then make again. And you can see that that make clean clears out all the object files and the executables, and make then builds everything. So it's going to build the implementation file, it's going to build the test functions, it's going to build main, and then it's going to compile it all and put it into a file called a.out in the build directory. So if I say that .build/a.out and run it, it says the first array passes, but the first test passes, but the second test fails. If you look at the tests, the first test, let's see if I can find it here. The first test passes in an empty array. There's an empty array here, and checks to make sure that the result is 0. Of course, the implementation that's in there returns 0 no matter what the array is. So that test actually passes because 0 is the correct answer. But the second test, which it passes in a non-empty array, which should have an answer of 6, the test fails. So that one fails. And the way, this is a very simple testing framework. As soon as one test fails, the thing says, forget about it, I'm done. So if you want to run a particular test, you can just comment out these lines that you don't want to test and focus on that one particular test if you wish to. But at the end, it's going to need to pass all these tests. When you submit your code to GitKeeper, I run not only these tests, but also a bunch of other tests that I've written to do a little more thorough testing to make sure your code is fairly rock solid. So that's the way that is. If you're not wanting to use Cloud9, you can build a Docker instance or a Docker container to run this code. If you want to do that, let me know and I'll help you get that going if you can't figure it out from the Docker file. And but if you want to use Cloud9, then you don't need to do any of that. pSource is, it turns out you can link the implementation file to what's called an extension of Python and call it from Python. So that's what happens in pSource. You don't have to fiddle with any of that. But you can look at it if you're interested. If you want to play with it, be my guest. And then that's it. So please be sure to ask questions if you have any, and I'll see you guys next time.